Well, hello everyone. I wanted to give you some ideas for a midterm strategy, and I'm aiming this at people who just want to survive the course and get on with their life. For them, a C is good enough. And so uh, that's where this thing is pointed, this video. Now, what I've done here is create this little spreadsheet that shows if you get 90%, and that's for the course in general and for the test in particular, the midterm, if you get 90% of the points, or in this case 90% of the 30 questions, you'd get an A. Well, 90% of 30 means you have to get 27 questions right. You can only miss 3. That's a hard road to hoe. For a B, you're going to need to get 80% of the 30 questions, or 24 right. You can only miss 6. And for the desirable C, the goal here, we all want to get C's at least on this thing. You need to get 70% of the 30 questions, or 21 questions right. Now, my argument here is what you want to do is get the first 6 questions right. You want to go 6 for 6 on the first 6. They're all from chapter 1. They're by far and away the easiest on the test. You want to nail those first 6. If you do, if you get the first 6 right, there's only going to be 24 left. And if you can get 15 out of those 24, or 62% of what's left, in other words, if you can run a low D on the rest of the test, you can still pass the exam with a C, having got those first 6 right. So that's the goal. And that's my vision for this video here, is to help you get these first 6. And here's the study guide. I'm going to go through these first 6. I'm going to work a few, and then I'm going to create another video because I have to stay under the YouTube 10-minute limit. And let's get after this now. We're going to translate into algebra. 6 less than half a number. And this is the key phrase, less than. It's very tempting to think of it as this. In fact, I can't argue. I sympathize with you. If you say less than means that, I agree, it does. But in the context of chapter 1, less than always means subtraction. So that's the first tricky thing about this less than phrasing. The other tricky thing about it is the only phrasing I know of that causes you to reverse the order of the two numbers that appear to the left and right of it. The 6 is actually going to go to the rear. And the half a number, let's call it the number n, and let's take half of it, goes to the front. So there's two tricky aspects with this less than nomenclature. And I think you could see that that answer exists. It's right here. And I don't suspect you're going to have much trouble with this problem after practicing a little bit with this less than phrasing. This other problem number 2, though, is a slightly different thing. They ask us to calculate using the order of operations. And I'm going to share with you after the exam the results for the whole entire class on this problem. I think that basically 25% of the class is going to miss this, but I hope to circumvent that by making this video. Not because this problem is hard, but because it's very easy to make an error on. It's simply human nature to make errors, and there's a lot of calculation going on here. Remember the order of operations, we had that mnemonic device. Please excuse really, my dear Aunt Sally. Of course, I put the R in because roots and exponents undo each other. And then we have division and multiplication, and then we have subtraction and addition. And I wrote this slightly backwards just to drive home a point. For example, with division and multiplication, they're on the same level. They have the same power. You don't prefer one over the other. You don't do one over the other. Multiplication does not come before division. Rather, whichever appears as you go from left to right in the expression. So that means that ultimately this division is going to be done ahead of this multiplication because it's to the left of it. Not because it's more powerful, but simply it's to the left. And that's the place where the fatal error will occur for most people. Now I want to get after this problem. We're going to follow the order of operations, which means we do the parentheses first. And I'm going to get 2 minus 5 or negative 3. That's being squared. I'm adding 5 to that, dividing it by 10, and multiplying by 4 squared. Notice I didn't try and make too many moves here. I just made one move. And that's because we don't want to be answer jumpers, particularly on the midterm exam. Plenty of scratch paper, take our time, and work our way through it methodically. Now we're going to do these exponents, and we're going to get this. Negative 3 squared is positive 9, but it's being subtracted. I have this addition, this division, this multiplication, and 4 squared is 16. And now we're good to do this division. It comes ahead of this multiplication. 5 divided by 10 is 1/2, and it's being added. So I have 1 minus plus 1/2 times 16. And now we're good to do this multiplication. 1/2 of 16 is 8. So I have 1 minus 9 plus 8. And we'll just finish this off by going left to right. 1 minus 9 is a negative 8 plus 8. And those two are inverses of each other, and the answer is 0. Now what I suggest you do is on your scratch paper, make a note to return to problem 2 after the test is over and rework it. And see if you can duplicate your answer. If you can't, obviously you need to think a little harder about that problem. Alright, now let's get on to the third one here. And I've got to scroll a bit. Solve for x. And this is a single unknown, one equation and one unknown, and it has fractions, and that's what makes it tough. Well, this one isn't that tough. I'm going to actually play a little game with you here. I'm going to ask you to imagine that my finger's covering this up right here. So, what must this be? 1/5 plus what is equal to 4/5? I think you see that whatever under here, it has to be 3/5, because 1/5 plus 3/5 equals 4/5. I call this idea the cover-up technique. It's just another way of thinking about things. This has got to be 3/5. Whatever is here has got to be 3/5. And the only way we can change it into 3/5 is by putting in some x. And lo and behold, if I let x equal 2, I'd have 6/10. And 6/10 is really 3/5. So the answer here is x is equal to 2. And rather than actually work this problem out for you, I think most of you can handle this problem. You would know to clear fractions, you'd multiply both sides by 10. And that would rid yourself of the fractions, and we'd be in section 1.3. Rather, what I suggest you do, since I've seen so much of your homework and I've seen some of these midterm study guides, some students have sent them in, is no one checks their work. And since this is a midterm, this is definitely the time when you want to do that. Suppose you worked this out and you came to this answer. Would you check it? I suggest you do on the midterm, that you put in 2 for x right there and see if you create a left-hand side that's equal to a right-hand side. So let's just do that. Let's just check this thing. Let's let x equal 2. And we want to know if it equals to 4/5. We're curious. Well, how do you multiply fractions straight across? You're going to get 6/10 here, and 6/10 is really 3/5. And 1/5 plus 3/5 does in fact equal 4/5. So it does check. And that's all I wanted to show you here, is the necessity of trying to check your answers as much as possible, especially on the midterm. Okay, now I'm going to stop here and return and work those final 3 problems. Be talking to you in a second.